All right, we're going to look at section 11.3, which is on p-series and the integral test. I want to talk about p-series first. A p-series has the form the sum of 1 over n to the p. And n starts at, sometimes it starts at 1, sometimes it starts at a slightly higher number, but anyway, n goes from 1 to infinity. And the thing you need to know about this is this fact. P-series converge if p is greater than 1, and they diverge if p is less than or equal to 1. So in the previous section we learned about geometric series, and here we're learning about p-series. These are two types of series that are well behaved, and we're going to later compare other series to these two types. One thing I want to mention, note, when p equals 1, we get the harmonic series. And we know that the harmonic series diverges. All right, let's look at a couple of exercises or examples. So this is a p-series. And this one converges because p is greater than 1. All right, let's look at another example. Let's look at this. We're going to go, n goes from 1 to infinity of n cubed plus n over n to the 4th. Now, right off, this isn't a p-series, but we can break the summation into two parts. We can break this into n cubed over n to the 4th plus n over n to the 4th. So this first one becomes 1 over n, and the second one is 1 over n cubed. And I can write that as two summations. And if we look at these, both of these are p-series now. This one, p equals 1, so this one diverges. This one, p equals 3, and so it converges. But if we add them together to get the original series up here, we add those together, we get basically infinity plus some finite number. So altogether, this equals infinity, and so the original series diverges. Pretty much anytime you add something that converges to something that diverges, diverge is going to win. Let's do another few examples. Let's say we have 3 over n to the 4th power, and going from 1 to infinity. Now, the fact that there's a 3 on top instead of a 1 doesn't really matter. You can factor that out to the front and get 1 over n to the 4th. N goes from 1 to infinity, and so this p is greater than 1, so therefore this is going to converge. All right, one more example. Suppose we have 1 over n plus 4, and n's going from 1 to infinity. Now you might look at this and say it's P series, but it's not quite because of that plus 4 on there. If you ignored the plus 4, then you might say it looks like the harmonic series, which diverges. And in fact, this thing does diverge. But let's show that a little bit more rigorously. If I start writing these terms out, when n's going to start at 1, so my first term is going to be 1/5. Then plus 1/6, plus 1/7, plus 1/8, and so on. Now, down here below this, let's write out the harmonic series. Okay, so that's the harmonic series, and we know that this adds up to infinity. So let's break this up into a few pieces. This and this. Now this is A and this is B. And so up here, this is just B. If you look at this bottom piece here, what this tells us is A plus B equals infinity. And if you look at A is a finite number. We could work out what it is, but it doesn't really matter, because what we get over here is B is infinity minus some finite number. Who cares what it actually is as long as it's finite? That tells us that B is infinite. So this series up here was just B. And actually, I realized I should have put the parenthesis around here. So B is everything all the way to the end. So B is infinity minus a finite number, so B is infinite. And so this thing diverges.